Okay, it's time to begin. And before we begin, I want to make a few comments. I've been looking at assignment 1. Most of you have them turned in by now. There's one or two people who haven't. One student who just joined the class and is running behind. And anyway, I'm not quite finished evaluating them. You should get them sometime later this week, some like Wednesday or Thursday, okay? That's how soon I'll have them. But I wanted to make a few comments. There's several reasons why I give you the first assignment. The first one is because probably the most useful tool you will ever have for managing projects is a spreadsheet tool. And I wanted everybody who hasn't already learned to use spreadsheets to learn to use spreadsheets. So one way to do it is to give you an assignment right on the first day where you use a spreadsheet. And one of the things you should think about is making sure you understand that spreadsheet. Look at every formula and say, why is this formula this way? What is it doing? That will be very valuable to you if you haven't already figured that out. Because everything is there for a reason, and feel free to ask me a question if you're not sure, why did I do this? And that sort of thing. Also, there's a frequently asked questions file out there on the Blackboard that answers a lot of questions on that first assignment. The second reason is that one of the most important things, if you're in charge of a project, whether you're a team leader or a manager of a big project, is you are going to have to report to whoever is your boss what's the status of the project. And a tool like the one that you did in assignment 1 is a very good way to track the status of a project. Now, one of the things that some of you apparently didn't quite understand, and that's one of the reasons for doing assignment 1, is assignment 1 is a work breakdown structure for your project of taking this course. And when you list all the different tasks and activities in your work breakdown structure, where do you get them from? You get them from the statement of work for all the assignments. So take every assignment, assignment 2, 3, 4, whatever, and look for places where it says work to be done, or tasks to be performed, or deliverables to be produced. Everything like that should show up one way or another in your work breakdown structure. Now, in some cases, the work to be performed is a really big task, in which case you might have several tasks connected to it. But that's just so you understand. Now, something else that I wanted you to experience. The very first time I ever was assigned to a major project, they dumped a box of paper on my desk. It was about this big, just a whole box of paper. And in that paper there were about 24 documents of all kinds. And the guy who gave it to me said, I'm doing you a favor because normally you'd have to go find all of these. I've already found them for you. Here they are. Your job is to figure them all out, how they relate to each other, which parts of them apply to you, which parts of them don't apply to you, and make sense out of it all. And I spent the first week of that project just reading through those documents and trying to draw in my mind, oh, this one explains this, and this one referred to this one, and trying to make sense out of all that. That's part of what I asked you to do in assignment 1. I gave you a whole bunch of documents all over the place. And part of your job for assignment 1 was to look at all those things and figure out how they relate. And part of the reason for that is because that'll enable you to do a much better job on assignment 2 and 3 and 4 and 5. So when you get your comments back later this week, some of you may get comments that say you didn't understand, you're supposed to do it this way, not this way. But that's not the end of assignment 1. Keep in mind, assignment 1 is to set up a spreadsheet for tracking your progress, and then every week through the semester you're supposed to track your progress. And so what we're trying to do is to help you do it correctly, help you understand how it works, help you understand all the parts, et cetera, et cetera, et cetera. So I wanted to give you that general feedback relative to assignment 1. I've graded almost all of them, at least in my first cut through, but I've got to go through them again and try to make sure I'm not missing things and so forth and so on. If you ever have the job of grading assignment 1, you'll understand what I mean. It's actually a fairly hard assignment to grade because there's so many ways people can get it wrong. But anyway, I wanted you to understand how important it is because it's really teaching you a basic fundamental tool that you will use all the time whenever you're responsible for a project. Okay, now let's talk about tonight's lecture. As I said earlier, we start off with very high-level concepts and then gradually focus on more specific concepts. At this point, you should have done your first attempt at assignment 1, and you'll be getting feedback soon. And so now it's time to think in terms of, well, what do I have to do for assignment 2? And that's why we're now talking about planning, because assignment 2 is the first draft of part of your plan for doing this Mr. Television project. Assignment 2 is all about this Mr. Television project. It has nothing to do with assignment 1. Assignment 1 is all about you taking this course. Two totally different projects. The work breakdown structure for assignment 2 will be totally different in format and designed for developing software, whereas the work breakdown structure for assignment 1 is for taking a class. Two very different kinds of projects. Okay, so let's talk about planning. In this module, we're going to talk about a general framework for planning a software project and some of the initial activities involved in doing that kind of planning. And one of the most important things to start with is this quote from Dwight Eisenhower, who was one of the presidents of the United States, and he was the head of the Allied forces in Europe during World War II. He said, "Plans are nothing, planning is everything." Now, what did he mean by that? Plans are nothing because all they are is guesses. A plan is your best guess as to how things will happen. As soon as you complete a plan, it's obsolete because you learn things after you finish the plan that would have caused you to change the plan. Now, it's not immediately totally useless, but the point is it starts to become out of date. It doesn't mean you don't use plans. Let's talk about why you use plans. First of all, they give a framework that everyone on the project can relate to. It's a starting point for everybody. Everybody on the project is starting from the same basic plan. Now, if you only have 3 people on your project, that's not necessarily a big deal. But if you have 100 people on your project, it's really important for them all to be basing their plans, their activities every day and every week and so forth, based on the same overall plan. And that's what plans do. They give you a framework. They say, who's responsible for what? How do you relate to each other? Who expects what from whom? They're information that helps you organize. How are we going to break our project up into teams? Who's going to be responsible for what? They're also a basis for deciding how to allocate resources. Let's say you're the manager and you have 50 programmers. Which programmer do you put on which part of the project? Well, it's not always an easy question to answer. But that's what a plan does. A plan gives you an overall picture. We probably need about 5 people on this part and another 7 over here and 2 over there or whatever. And if nothing else, a plan is a basis for deciding whether or not to go ahead. Because sometimes what you learn when you develop a plan is we're not ready to do this. We shouldn't try. We should back out. We should say no. Most of the time, hopefully, that's not the case. But if you've ever played golf, a plan is a little bit like that. Your goal is to hit the ball and have it go right in the hole. But if you've ever played golf, you know that that doesn't happen very often. What usually happens is the ball goes somewhere closer to the hole than where you are now, but you have to make corrections. You have to hit the ball again. You may have to get a few extra balls because you lost some in the water or something. But the point is that that's what planning is all about. You make a plan, you start following the plan, and then you start realizing, hey, the plan isn't perfect, we've got to make some adjustments. On the other hand, when General Eisenhower said that planning is everything, what did he mean by that? His point was the act of planning, the act of developing a plan, is where the real benefit comes. Because it forces you to think about things. It forces you to figure out what are the alternative ways to do this, and which way am I going to do it, and why am I going to do it that way? It gives you knowledge so that when things don't work out, you have already thought about the alternatives. You thought about the alternatives when you made the plan. Maybe you said, well, we're going to use this compiler because we think it will generate code that will be fast enough. But you have already thought about, well, what compiler will we use if this one isn't fast enough? Well, there's another one over here that's faster, but it may be less convenient for some reason. You've already gone through that thinking process. So if you get into the project and you realize the compiler you've chosen isn't fast enough, you've already thought through what the alternatives are, and you can just say, well, we better switch over to this other one. You don't have to solve these problems while you're in the midst of doing the project. You've already thought them through when you did planning. And the way you can tell that someone has planned well is that they can handle the unexpected results effectively, because they've thought about what happens if it doesn't work out the way I'm planning to. They've given some thought to that. This knowledge that you get from planning is the really valuable thing. And if nothing else, you know when not to follow the plan. That's an interesting way of looking at it. If you've really done good planning and you've really produced a good plan, then you know when you shouldn't follow it, because you know what assumptions went into the plan. You know what conclusions you based it on. And if you find out that the reality of the situation says that's not going to work, then you know to change. Think about you're driving a car and you're driving on a highway and all of a sudden you see a traffic jam. Well, if you've planned your trip, you might say, oh, well, obviously we're not going to go anywhere on this highway, but I know there's another highway over there we can take. It's not as fast, but at least I know where it is. Just turn right here and go 5 miles and we're there. That's an example of knowing when not to follow the plan, because circumstances are different. All right, this is a model of the management process. You plan, you do, you monitor, and you assess. I believe we talked about this before. And the idea is that management is doing all these things on the outside. You're planning what to do, you're starting to do it, you're watching what happens, you're assessing how things are going, and a lot of the time you end up revising your plan, changing the way you do things, continuing to monitor, continuing to assess. Now, if you imagine that this is actually a 3-dimensional picture and you're only looking at a 2-dimensional version of it. So imagine we turn it 90 degrees, and there's your software development, and the management activity is that spiral going around the outside. And the software development is proceeding, and management is doing all those things on the outer circle over and over and over again to try to keep things in line. That's another way of looking at what management is doing on a software project. Now here's another way of looking at it. Software development is in the middle, and management is doing 2 things. The ones on the bottom I call management are really the administrative end of things. The ones at the top, called risk management, is dealing with all the uncertainties, dealing with all the things that might go wrong, finding out whether or not they are going wrong, and then if they are going wrong, taking appropriate action. Here's another model. And there's all sorts of different ways of thinking about this. And no one of these is the perfect way of thinking about management. But it's just that you might want to think about all these different pictures and what they might be telling you. This one is telling me that ultimately the principal purpose of management is to manage risks. Now, here is a model that is kind of modeled after the way you develop software. You understand the need, you define how you're going to do it, you generate all the detailed plans, and then you go do it. And you can think of this as kind of a waterfall process, a waterfall life cycle for managing a project. Understand the need, that's understand the requirements. Define the approach is high-level design. Generate detailed plans is generating more detail in your plans. And then execution is writing the code and testing it and seeing how well it works, and if it doesn't work, making corrections. Except we already talked about how you go around this cycle over and over and over again. So here's another way. It's really the same diagram as this one, except that I've put it in the form of a circle. And the idea is you continue going around this circle constantly if you're in the management mode. You are constantly trying to figure out what's going on and changing your understanding based on what's happening. For example, the customer changes their mind about requirements because of something you learn along the way, and therefore your understanding of the need changes. Therefore, your approach may change a little bit. Therefore, your detailed plans may change a little bit, which may affect the way you run the program, and so forth. I'm going to use this diagram a lot, so it's kind of the where I'm going to tie things together. Management tends to focus on the top three activities, whereas the practitioners, the programmers, and so forth, tend to focus on the bottom. But they all need to be aware of all of it. So what I've done here is I've taken that same circle, understand, define, generate, and execute, and I've connected it to a box that says manage risks. And this is an important way of looking at things because this is management standing a little bit apart from the details and saying, what risks lie ahead? What risks look like they're about to happen? Whatever the nature of the risk is. The risk could be that the computer isn't fast enough. The risk could be that you don't have enough people who know a certain language. The risk could be you've run out of money before you finish the work. I mean, there's a lot of possible risks. But the idea is that's a major job of management, is to figure out what's going on risk-wise and what do we do about it. Now, you'll notice some of these arrows go up. Those arrows represent management observing or monitoring what's going on. They represent anything you do, having a review, collecting data and analyzing the data, whatever it might be. The arrows that are going down represent management making changes based on their assessment of the risk. So, for example, let's suppose you decide you don't have enough programmers who know Java, and it's becoming very evident that you're going to need more. That might be based on one of the arrows going up. And therefore, management decides to reassign programmers so that the Java people who know Java, are used where they're needed. And that is an example of an arrow going down. Now, this picture is the exact same picture, except I try to show how it relates to the modules of this course. We are currently in Module 6, and we are going to talk about understanding the need in the next several slides. We're also going to talk about defining the approach. The rest of this evening, Modules 7 and 8, are going to finish out the define the approach part. Next week, and for several weeks, in fact, past the midterm exam, we're going to talk about this box that says generate detailed plans. And then after the midterm exam, we're going to focus on things in this execute and monitor. We're also going to talk about risk management after the midterm exam. So this is kind of a map of how the course relates to this model. Now you might say, well, how come I need 20 or so modules to do detailed plans and I only need a part of a module to do this? That's because it shows you the relative amount of energy you put into each of these. Understanding the need isn't necessarily something that takes you a lot of energy and a lot of time to do. Defining the approach takes a little more, but not that much. Generating detailed plans is where you do an awful lot of the hard work. If you're a manager, you typically have people to help you generate some of these detailed plans. In fact, the way I learned to be a software manager is that I was a software developer, and then the boss said, I want you to help me do some of the detailed planning. And then I learned how to do that, and then I got a little more responsibility. And over time, I became a manager telling other people to do some of these things. So well, let's talk about initial planning. That's what we're going to focus on for the rest of this evening. And initial planning is the term I use for these first two boxes. You can think of it as understanding the requirements at a high level and understanding how you're going to approach the problem at a high level. That's what I mean by initial planning. It's the kind of planning you do. For example, imagine that your boss comes and says, we're thinking of bidding on a project to do such and such. And I want you to tell me how long it'll take us to do it and how much money it'll take. I don't want you to plan in detail how to do it. I just want to give a rough estimate of how much money it's going to take and how much time it's going to take. That's a very common scenario for a person in any kind of a management role or a leadership role. So you go through these two steps. You understand what needs to be done. You define an overall approach at a high level. And say, boss, I think this is going to take about 15 people, and it's going to take us about 6 months, and it's going to cost about such and such, whatever. That's what initial planning is. Another scenario where that might happen is if you do contract work. A lot of the time the way that works is somebody sends you a request for proposal, and your job at that point is to respond and say, we will do this job that you've asked us to do for this much time, and it'll take us this long to do it, and it'll cost this much money. And that's called a bid. And you say, that's what it'll take us to do it. And other companies are also bidding. And what you want to do is have a bid that is competitive. That is, you don't want to be more expensive than everybody else. But at the same time, you want to have a bid where your company won't lose money if they win the contract. So you have to be reasonably accurate in terms of what it's going to cost you to do the job, and hopefully reasonably smart about doing the job well so that you don't cost a lot. In today's Dallas paper, or maybe it was yesterday's, there was an article about a local school district that is bidding on getting artificial turf on their football field. And they put out a request for proposal, and 6 companies bid on the job. And they all bid different prices, and they all bid different approaches, and so forth and so on. And now there's a big article about how the school district is deciding which one to select. And they're not necessarily going to pick the cheapest one because they think the cheapest one has an inferior product. They're going to pick the one they think can do the job, can get it done in time, and can have a decent product at a decent price. And that's how that process works, a competitive bidding. And it's a very common scenario for certain kinds of companies. Other companies don't work that way at all. Other companies, somebody in the company decides we're going to do this, and they ask you to do the software for part of it, and they ask you how much is it going to take. And you have to estimate it and tell them. So that's what initial planning is all about. It's not working out the details of how you're going to do it. It's coming up with enough of an understanding that you can be in the right general ballpark or in the right range of approximately what it's going to take to do the job. So the idea is what they call scoping out the project. How big is this? And how could we do it? And what software lifecycle would we use? And what language would we use? And about how many people would we need? You do it when you get a proposal, sometimes when you get a contract, sometimes the boss asks you for an estimate. And the thing to remember is that it is not a detailed plan. So you know you're going to have to update it later on. You know you're going to have to revise it and come up with more detail later on. But the idea is you want to get a general idea of what it's going to take. So let's talk about the first step, understand the need. The first thing you have to do is figure out who is the customer, what do they want, how well do they know what they want, because a lot of the time they don't, and what are they expecting? What matters to them? Now, in some big projects, you don't worry about as much of this as others because somebody else is figuring these things out and then telling you by giving you a document that says this is our summary of what we think the customer wants. For example, you're working for an automobile company and the company decides we're going to make a new kind of car. We're going to make a crossover between an SUV and a sedan. And they did some market research and concluded that there's a market for this and this is the kind of features they want, and say, well, they'll write all that down and they'll give it to you and they'll say that's the requirement as we understand it. In other times, you have to go talk to the customer to find out what they want. One of the key points about this diagram is that there's many, many different ways that you can identify customer needs. A lot depends on the nature of the kind of software you're developing. And it's important to know exactly who's involved. For example, the sponsor is the name I use for the person or organization that's paying for it. Now, that's not always the same as the customer, as the end user anyway. For example, if you're making clothing, then the end user is whoever's going to buy the clothing and wear it. But suppose you're making baby clothing. Then the customer is the baby, but the sponsor is the parent of the baby who's going to buy the clothing. And so you have to understand what the baby will be comfortable with, and you have to understand what the parent will like. And sometimes that's not the same thing. The parent might care about the collar, whereas the baby doesn't care, for example. So you have to understand that sometimes there are all kinds of people involved in this process. And part of your job is to make sure you understand what all of them think and what they all want. Here's a typical diagram of the various people you might have to consider to be part of your customer. The end user, this is the person who's going to have to use whatever it is you come up with. The champion is the person who's paying for it. It could be the company that this person works for. If this is a child, this could be the parent of the child. There's all sorts of possibilities. There's a program manager. That's your boss in the project, or your boss's boss, person in charge of the whole project. There's the systems engineer. That's the person who's designing the system. We talked about that in the previous two modules, or previous two classes. Then you have this guy here at the legal department. His job is to keep you out of legal trouble. But he may impose requirements on you that you think don't make any sense or you think just is hard to live with, but you have to live with it because there may be some safety issue, there may be some who knows what issue. That's why they hire lawyers to do that kind of thing. This is a diagram. On the left is sometimes the scenario you face when you first get involved with the project. There are all these different customers, all these different people who think they know what you're supposed to do, and they all have different opinions. And you're the green dot. And all those little arrows are the customers pulling you in different directions. Now, if you've ever studied medieval history, you know that there's a form of torture where they tie a horse to each of your limbs and then tell the horses to all run in different directions, and you're in the middle. And you can imagine what happens. You don't want to be in that position when you're a software manager. So what you want to do is move things to the right. You want them all heading in the same direction. And how do you do that? Well, sometimes you just have to use your imagination and your cleverness to get them on the same page. For example, have a meeting with more than one of these people and get them to agree on the same thing. So that, you say, well, you're telling me this, you're telling me this. Can you two agree on what I should do? And it's one of those things that in theory you shouldn't have to do, but in practice you have to do it. Because if you don't, you're going to get pulled two ways, or more than two ways. Now, this is a little diagram of the process you follow when you're understanding the need. Your inputs are whatever is available to tell you what the customer wants. And this could vary tremendously depending on the kind of project. For example, the customer may just communicate something they need. I wish I had a program that would do this for me. Or there might be an actual formal request for proposal. This is usually common in a major effort. A draft statement of work, that's an interesting one. Sometimes the customer will give you a draft statement of work. Now, imagine if on assignment 1 I had given you the statement of work and I said, that's a draft statement of work. You tell me if any of it should be modified. Now, why would you want to modify the statement of work? Well, you look at it and you say, it's going to be hard for my company to do it that way, but if we change it in this fashion, then it's a lot easier. Because let's suppose the statement of work said, you have to write the code in C++. And all of your employees, none of them knew how to write code in C++, but they all knew how to use C#. Well, you might say to the customer, well, if you let us use C#, we can do it cheaper because we don't have to train people in C++. And so that's where a draft statement of work comes in. Sometimes the customer says, I think this is what I want, but I want you to comment on it. This is a very common scenario when your company has technical expertise that the customer does not have. For example, let's suppose you are a company that makes airplanes, and your customer is an airline. And they say, we want a new airplane that has all these characteristics. They might give you a draft statement of work and say, this is what we think we want. Now, they don't know how to build airplanes. You do. And you come back to them and you say, well, what you put here is unrealistic, but if you'll change it to say such and such, we can do it. And you negotiate that with the customer and eventually get a real statement of work that you mutually agree to. So that's what a draft statement of work might be. Sometimes all you have is customers' ideas, and they want you to propose something. Whatever it is you have, that's your input. And your job is to figure out something a little more specific. For example, you take a draft statement of work and produce a more final statement of work. You take all that you know and produce at least a high-level statement of the requirements. Make a list of the expectations that the customer has mentioned. Any commitments. One of the things that happens is your management makes commitments to the customer. You have to know about them so you can make sure to deliver. Whatever the idea is, the output of this is something that's a little more specific about what the need is. So let's go back. A statement of work is a document or some other artifact that says what work is to be performed and what products are to be delivered. Think about the statement of work for assignment 1. That's what it did. It tells you what to do and what to deliver. Statement of work for assignment 2 does the same thing, and so forth for all the other ones. That's why I express all the assignments in the form of a statement of work, so you'll know what a statement of work is. Although they're all done differently because there's many different ways of doing a statement of work. But these are the essential elements of a statement of work. And I like to think of it as the requirements for the project and the process. It's not the requirements for the product, which are usually in a requirements specification or something like that. It's the requirements for the project. You're to do this, you're to deliver this, you're to meet this schedule, you're to follow this standard, whatever it might be. It may also include information like standards to be followed, methods to be used, budget limitations, schedules to be met. Another way of looking at a statement of work is it's the basis on which a contract is usually written. When you bring the lawyers in, they take the statement of work, translate it all into legalese, and deal with all kinds of issues that statements of work generally don't worry about. Here's a simple statement of work. Develop a spreadsheet program in C++ that runs on PCs and tablets under Windows 8. And that's what you're supposed to do. Here's what you're supposed to deliver. Source code, help files, load module of the spreadsheet program, installation guide, and maintenance instructions. Now, that's a very high-level statement of work, but it does tell you what you're supposed to do and what you're supposed to deliver. And the advantage of that is you know very clearly what you're supposed to do. You can probably imagine how you might start to put together a work breakdown structure that represents this activity. Here's things that might be there but don't have to be there. Something about the process to be used. Sometimes the customer wants you to follow a particular process. For example, in Europe, you may have to be ISO 9000 compliant. This is a process requirement. If you're doing anything for the United States Federal Aviation Administration, like building a new airplane, there's certain standards you have to follow so that they can attest to the safety of the airplane. You might have statements about where the requirements for the product are to be found, like in a separate document or something, or in a list of use cases or user stories or whatever it might turn out to be. What you typically don't have in a statement of work, but do have in a contract, are things like payment schedules, awards, and penalties, and that sort of stuff. Now, I want to talk a little bit about requirements and how they are developed on a project. There's this general notion that requirements kind of develop over time and start with something relatively vague and go to something more specific and then go to something even more specific. And so in some theoretical sense, you'd like it to work like this. The customer has a vague idea, they meet with you, and you come up with a statement of what you're supposed to do, then you clarify the statement and get more specific, and then when you know what you're really supposed to do, you start doing the project. Except that that is not the way it usually works. What usually happens is you go through that process over and over and over again. And the reason is because it takes a long time in most cases to figure out what the requirements really are for software. So this is why you have iterative and agile lifecycle models, because you know that this waterfall-ish kind of approach probably won't work for most projects. In most projects, you're going to have to come up with a rough idea, maybe build a prototype, and then realize, well, we didn't understand the problem very well. We need to revise our understanding of what needs to be done, do it again, and maybe keep doing it again and again and again. A concept might be, I want a spreadsheet tool for my new tablet computer. In fact, I had a job very similar to this once early in my career. The company was building a new computer and they wanted a particular kind of software to run on that computer. And that was all I had at the beginning. Well, over time you refine that, you develop something more specific. In this example, develop a spreadsheet tool that's better than Excel but looks and functions just like it and responds to voice commands as well as hand gestures. I mean, I just made that up. But the idea is this is a lot more specific than that. And then eventually you translate this one on the left into this thing on the right. Here's exactly what's supposed to happen when this happens. And the thing on the right is usually called a specification. And the first part of that word is specific, and that's what its specification is. It's a specific description of something. One of the most important things to keep in mind when you're developing requirements is to know what you're going to do to test that you satisfy the requirements. Sometimes these are called test requirements. There's other words in use. The point is, it's something that says, how am I going to test to make sure I satisfy the requirements. And the important thing to keep in mind there is that if you don't know how you're going to test it, you probably don't know enough to build it. If you build it and don't know how you're going to test it, what most likely will happen is you will think it's fine and the customer won't. What you want to do is to make sure that you and the customer agree on what tests will be run to make sure it works. Now, I don't mean you have to have all the tests written, but in a general sense, you have to know we're going to test this, we're going to test this, we're going to make sure it does that, we're going to make sure it does that. Here's some examples. The spreadsheet must run a standard spreadsheet test suite. There are companies out there that actually do that. For example, you take the C++ language. If you're writing compilers for C++, there are standard C++ compiler test suites that you can run through your compiler to make sure they work correctly. Or you say we're going to have to run through each command and we'll inspect each screen for proper color speed and readability. Now that's not very specific, but at least it says how you're going to test it. We'll apply the help command and at least 80% of the people have to understand the help guidance. So, that's another way of specifying. The point is you don't have to have the detailed tests written at this point, but you have to know in general how you're going to test this thing. A very common problem is for the customer to have something going on in their head that doesn't agree with what's going on in your head. And you both think you understand each other, but when you get to the end of the project, you don't. And that's a little late to find that out. So it's important to say, here's how we're going to test this. This is the test we have to pass. That's what happens on Olympics, for example. They say you have to go down the hill, and here's the characteristics of the hill and all this kind of stuff, and whoever gets there first is the winner. That's the way they specify the test step of the Olympics. Now, where do requirements come from? Well, on a small project, you talk to the customer. And most agile techniques claim that frequent contact with the customer is an essential part of the technique. In practice, that's very hard to do. In practice, maybe the end user talks to this guy who talks to this guy who talks to this guy who talks to this guy, and by the time it went through 5 people, you're not necessarily getting the same story that the end user produced. And this is, unfortunately, a part of reality. You get conflicting views. You don't necessarily have contact with the end user. And so you have to be flexible enough to realize that maybe you don't understand the requirements as well as you should. If it's a big project involving much more than software, there's usually a guy called a system engineer who is the person who understands the big picture. Sometimes it's called a system analyst. It's a person or an organization that is designing the whole product. In this little example here, you're designing an airplane. And what they do is they say, okay, here's all the parts of the airplane and here's what they all have to do. We talked about some of that last week. And then they allocate the functions to different organizations. So here's the system engineer responsible for the whole airplane. And this little section down here describes the part you're responsible for. And they tell you, yes, this is the description of the landing gear, and you are responsible for the software for the landing gear. And you don't talk to the pilot, you don't talk to the passengers, you don't talk to the owner of the airline, you talk to the system engineer who's designing the airplane. Here's typically what happens. It's called requirements allocation. Let's take this example. The system engineer is supposed to design a 3,000-pound car that goes 0 to 60 in 9 seconds. That's the way the end user wants it. That could be the marketing department of the automobile company or something like that. The system engineer says, okay, in order to achieve that, we go through this process we went over last week called system analysis and design, where they say, okay, here are the various parts of the car, and here's the characteristics of each of those parts. Now, some of the original requirements, like 3,000 pounds, are very easy to allocate. The engine gets 500 pounds, the transmission gets 100 pounds, and so forth and so on. And it's easy to see how each of these weight requirements combines to produce that number. But others are much more complicated. For example, 0 to 60 in 9 seconds. Well, there's a design of an engine and a design of a vehicle process that goes on here that might translates into this is the horsepower needed on the engine, and this is the torque needed here, and this is something else needed here. And it's hard to directly relate these requirements here to this requirement here. There's a kind of a complex way of getting from one to the other. This is one of the reasons why requirements tracing is an important concept. Being able to have something that tells you, if you change, let's say you're building the engine and you say, we can't get more than 200 horsepower with the other characteristics we've been given. You have to know which of these original requirements might be affected. And the way you know that is through some kind of a tracing mechanism. A derived requirement is a requirement that you can't immediately trace directly back to the original requirement. It's something that, like this 250 horsepower on the engine, somehow or other they got that out of this system analysis and design process. The trace mechanism is what tells you that this requirement of the software relates to this requirement of the customer, relates to this mechanical requirement, so that if somebody has to change something, you can figure out what other things may need to be changed. And on a big project, that can be a major, major issue. A very common scenario is the customer changes their mind about a requirement, and they say, what is the impact if I change that? You have to be able to respond to that. And if you've already written 500,000 lines of code, and they say, well, we want the database to have this new property, how do you know how much more code you're going to have to write and how much of the code you've already written you're going to have to throw away? Well, having this kind of mechanism helps you do that. Possible exam questions here. Explain the difference between a statement of work, a statement of requirements, and a list of acceptance tests. Explain how they all kind of relate to each other. And explain the role of requirements trace mechanism. Now, when I ask a question like this on an exam, the answer I'm looking for is something that you could explain it to a colleague of yours at work. I pretend I'm your boss or a colleague, and I want to know this because I didn't take this class and I don't know. I hear you saying, well, we need to do a requirements trace, and I'm saying, why? And I want you to explain it to me in words that might convince me. Other elements of understanding the need include understanding the customer's priorities. Sometimes you can't solve all their requirements, but maybe if you know which ones matter the most, that will help you decide which ones to focus on. Because if you give the customer 8 out of 10 requirements, if you miss the 2 that are most important, they're not going to like it. If you miss the 2 that are least important, they're going to be a lot more willing to work with you. There's also political, financial, and other kinds of constraints that might inhibit you from doing what you might want to do. There might be, we don't dare do it that way because we don't have enough money to do it that way, or we don't have the equipment to do it that way, or we can't afford it. I remember some colleagues of mine were in the data communications business, and the test equipment they needed to test their system cost $1.5 million. And the company didn't have the money to buy it until next year. So they had to design their schedule to not need the test equipment until next year. It's something they had to live with. Now, Appendix A of this module has a bunch of information about risks that come out of initial planning. This will be helpful to you when you do assignment 2. So I'm not going to go through them all. Now let's talk about define the approach. This is kind of like designing the project now that you understand what it's supposed to entail. And by designing the project, you're doing things like picking a life cycle model for the software, deciding how to organize, deciding what to do first, building your schedule, deciding various process details. This is essentially designing the project, whereas the first part is understanding the requirements of the project. This is another chart. The inputs to this were the outputs on the previous chart that looked like this. And the outputs are much more specific than the inputs. For example, a life cycle model, what's called an integrated master plan, an organization model, and various other things like that, which we're going to describe in a moment. Most of the outputs are project level outputs. They are not necessarily limited to software. So your job is often to make sure that the software-related issues are correctly dealt with at the project level. For example, an integrated master plan is a plan for the project, and a lot of it has nothing to do with software. But some parts of it do have something to do with software. And if you're in charge of the software, you need to make sure that those parts make sense. And typically what's going to happen is then you're going to get into the detailed planning phase of the project and produce much more specific plans for the software once you have reached these higher level general plans with the rest of the project. So let's start with the project lifecycle model. Just like software has a life cycle, projects have life cycles. And a typical project life cycle will have a series of phases where different things are supposed to happen. I've give you an example at the bottom. And what you need to know as a software person is, what is this life cycle model? What does it look like at the project level? By the way, this first module tonight is going to run a little more than 50 minutes, but that's okay, because remember I spent some time at the beginning talking about the assignment, so that's why we're running over, but we'll make up for it later. You need to know, where are you? And what is the goal at the project level for this current phase of the project life cycle? And sometimes that's not easy to get, because sometimes the people running the project haven't thought about it in as organized a way as they might. In an ideal project, the life cycle model for the project is defined by the project manager, with assistance from the technical staff, including the software people. The software manager's job is to understand this project level life cycle and figure out how software fits into it and maybe influence it somewhat. Unfortunately, most projects aren't that ideal. In a real project, you may have to prod people to do what they need to do. You may have to ask a lot of questions. Sometimes I was able to get project managers to do the right thing by asking so many questions that they had to start answering them. And that forced them to think these things through. And even if the project manager is doing that, you may have a mechanical engineer or an electrical engineer or a system engineer who needs to be prodded into giving you more information than they currently are thinking of giving you. And then eventually, you will be building a software lifecycle model. Another major thing that goes on in a big project is called an integrated master plan. This is just a plan for the whole project, where all the different parts of the project are planned as one big thing. What are the main things that have to happen? And the important point here is this is a plan for the project, not a plan for the software. Software is a part of this plan. Here's a little more detail about what's in an integrated master plan. And if you think about it, all it's doing is saying who does what and how for the project. This team is going to develop the electrical system, and this team is going to develop the software that runs on the computer, and this team is going to develop the chassis, and this team's going to do the marketing, and this team's going to do the installation, and here's how they're going to do it. Again, the software team, and in particular whoever's in charge of the software team, which is what this course is all about, is supposed to participate in the development of that plan, make sure that the top-level software tasks are properly represented, and to document that for purposes of software planning. You want to do your software planning in a way that's consistent with the overall project plan. And again, as with the previous stuff, you may have to push other people to get them to give you information that you need. A very important point, an integrated plan or an integrated schedule, as we're going to see a schedule in a minute, involves everybody on the project. So if the project agrees to a schedule, that's a project everybody has agreed to. Now, maybe they didn't all like it when they first came in. A common scenario is the project manager says, I want it done in 6 months, and the technical people say, we can't do it in anything less than a year. And they get together and they work something out, and they have a schedule that says we'll do it in 9 months, because they all figured out ways to come a little closer to what the other ones want. But the reason I bring this up is because if the project manager wanted it done in 6 months, and after developing this plan, you say we can do it in 9 months, and everybody agrees to it, then you can't say it's a risk that the software manager or the project manager wants it in 6 months. This project manager has already agreed that it's going to take 9 months at this point. So your integrated master plan is kind of your starting point. And similarly, there's a schedule that goes along with that called the integrated master schedule, which says here's all the parts of the project and how they relate to each other. It looks something like that. One time I was on a very big project. We were building all the electronic equipment for a helicopter. And it was a big deal project. And our building we were on the 4th floor of this building, and we would take the elevator up to the 4th floor. And when you got off the elevator, there was a wall about 30 feet wide that you faced when you got off the elevator. And every Monday morning, there was a schedule similar to the one on the slide here that you looked at when you got off the elevator. And the first thing you do is go over there and say, oh, what's changed since last week? And then every Friday, you would tell the schedule person, here's the changes in the software schedule if you're in charge of the software, or if you're in charge of the electrical design, here's a change in the electrical schedule. And the the schedule expert would spend the weekend producing a new schedule and pasting it up on the wall so that on Monday morning everybody saw this big new schedule. And I was at an aircraft company one, at Beechcraft I think it was, and they had something very similar. It was a big wall this one was about 50 feet wide, and the boxes and the arrows were all magnetic, and they would put everything on magnets on the wall, and then every week they'd update things, and by doing it at this level, they could tell at the project level what was going to happen. Now here's a little warning from Dilbert. He basically says, for lots of projects, people use sophisticated project management tools to keep track of what's going on. You collect the lies and guesses of all the team members and organizing them into instantly outdated charts. This is what it often looks like when you aren't doing a good job at this level. But I warn you that because you really need to do something like this on a major project. But a lot of the time people don't do it justice, and then they end up with schedules that aren't meaningful, and then people don't trust them. Okay, your role, if you're a software lead, is to make sure this is done right from a software point of view. Make sure that software activities are properly represented in the schedule. Make sure that other things are done in a sensible way relative to the software. And again, you may have to ask questions, ask people to give you answers, push people into doing things. That's part of the job. Now, again, I repeat, these are project level things. They are project level plans, project level schedules. They're not the software schedule. They're not the software plan. They are the big context in which you develop your software plan or your software schedule. But if you have a project where nobody's willing to do this at the project level, you may have to sort of fake it or do part of it yourself. For example, I'm doing some consulting right now for a little company that has not bothered to do an overall project schedule. And in particular, a lot of the stuff that software needs as inputs, there's no schedule for when they're going to be available. So what we've had to do is we've had to put together a sort of a high-level schedule for all these inputs and go to the various people responsible and say, can you get this done by this date so that we can meet our schedule? So we've, in effect, had to construct it from the bottom up. And our biggest challenge right now is the integration schedule, because there's all these different parts that have to come together. And for reasons that I won't go into, the people in charge of the overall project haven't bothered to plan the integration of the project. So we've had to sort of say, well, this is what has to happen for software integration. Now let's talk about how we integrate the software with everything else. And we've had to sort of do it bottom up. Sometimes that's how you have to do it. Okay, a word to the wise. The only thing worse than not having project level, or worse than having project level schedules that you have to meet, is not having project level schedules that you have to meet, because that actually makes your life harder. All right, everyone should agree with the integrated schedules and plans. So you should understand that. Then when you have finally agreed on these plans, they should be plans that everybody in the project has agreed, signed up, agreed to support. Another note, these things are not just developed once and then they're permanent. They are updated all the time. They're constantly being revised and refined. So you might have a starting point and an initial schedule, but you will revise it over time. Another thing that has to happen at the project level first is how you're going to organize things. Who's going to report to whom? Who's going to be responsible for what? And here's an example of a project. You have a project manager and you have different functions, and one of them is the engineering function, and there's a chief engineer responsible for the engineering function. And then under the chief engineer, there's a software manager, an electrical manager, and a mechanical manager. And if you're the software manager, you're responsible for all this stuff over here in this bubble on the left. And your job is to figure out the organization from here down. Now, this seems like, in many respects, a very logical way to do things, but it has a major problem, and that is the software team, the mechanical team, and the electrical team can all be operating on different schedules and different plans and not necessarily coordinating with each other. And then they may get to the point of integration and they say, well, we don't have this ready yet because we've put our priority over there, but you needed this part. In other words, there's a lack of coordination. And that gets to be a big problem on a really big project. So, a very common approach for a big project is what's called a team-oriented organizational structure, where at the overall top level you have a program management team or a project management team that has all these different people on it, and then when you get to the engineering level, you have engineering teams for different parts of the product. Imagine that the product is an automobile. You may have a team for producing the engine and a team for producing the transmission and a team for producing who knows what. And let's say this is the team for the engine. Somewhere in there's some software development activity. But there's also software development activity here, and there's software development activity over here. And if you're the software manager, you have to somehow be responsible for all those different software activities, except they're all parts of different teams. Organizationally, they're in different places. And that can make things a little bit challenging to manage. Here's another organizational issue that sometimes comes up. Some parts, let's say there's two companies teaming together, or two parts of an organization teaming together to work on a project. This is not an unusual situation at all. And some of the functions are specialties of company A and some are specialties of company B, but some are things either company could do. And usually what they do is they have some agreement. You're going to do this part, and you're going to do this part. Well, that part in the middle here is something where there's joint responsibility. If you're in charge of the software for this part for company A, you have to know the counterpart, who's responsible for the software for company B, and make sure you work together and figure out a way to have a joint plan and a joint schedule and all that kind of thing. That can be a challenge. They may not like to do things the way you do. They may prefer different tools. They may prefer different languages. They may prefer different life cycles. Okay, one of the things you need to do as a software manager is know who depends on you and who do you depend on from the other parts of the project. And one thing you can do, there's lots of ways to do this, and I have several slides about this that I'm not going to spend a lot of time on. But you need to know things like, here is a key thing that they're doing in the hardware team that I need to have by this date, and their current schedule is to have it by this date. And those two are close enough that I better pay attention to their schedule, because if this thing slips, it's going to cause my project to slip. That's a matter of knowing who you depend on that is outside your control. Similarly, you need to know who depends on you, so that if you have a schedule slip, you know how it's going to affect somebody else, and you need to let them know. One of the things you can put together is what's called a communication model. Who do you have to communicate with on the project, and who's responsible for what? And then here's a little Dilbert quote that basically is an important concept, which is, the real objective of business communication is to advance your career, which is not necessarily consistent with clear transfer of information. What is he trying to say there? Sometimes other people should give you information but aren't willing to do it. Why? Because they fear that if you have the information, they may lose some credibility, they may lose some power. If they tell you how to do it, then you might do it, and then they have a team of people, they want their people to do it, so they don't tell you how to do it so that they'll get the job of doing it. So one of the problems you run into in any kind of a business situation is the problem of intentionally not communicating properly. And if you're the software lead or the software manager, you need to find this out and try to resolve it as soon as you can, because you don't want to find out 2/3 of the way through the project that they won't tell you some key information that you need. But you do want to figure out who you have to communicate with, what their job is, and I'm not going to go through this little diagram here, but the idea is, here's a little example. The technical supervisor can communicate to the end user with technical design information but cannot make contractual commitments. The legal department can do contractual commitments but not technical commitments. Now, this is the kind of distinction that an organization needs to make so that people don't make commitments they're not authorized to do. You need to work all this out. What are people authorized to do? One of the major things you want to do on any project, on any part of any project, is who's responsible for what. And there are four widely accepted concepts of responsibility. There's responsible, meaning the person who does the work. Authority means the person who approves the work. Consultant means someone who should be consulted because they're an expert on it. And an informee is someone who needs to know what's going on. Maybe they depend on it, maybe they are going to be affected by decisions you make, whatever. And there's an example here that I don't have time to go into. I'll let you go through it by yourself, but I wanted to get to this slide here. There's something called a RACI chart, which stands for responsible, authority, consultant, and informed. And here's an example of a RACI chart. I got this off the web. Here are in this case, a bunch of documents, a bunch of plans. Here's a bunch of roles on the job, on the project. And this person is responsible for this person approves this, et cetera, et cetera. And the idea of a RACI chart is it's a very simple way of explaining who has what responsibility. And it's a very compact and efficient and simple way to clarify that. And I've been in meetings where people debate for hours over what letter should go in what box, because they're saying, no, I should be responsible. No, he should be responsible. But it's important to work those things out. Okay, I'm going to talk about some other things in the next two modules, such as the software process and the software development plan. But what I wanted to do at this point was talk about the big picture at the project level, so you understand the context in which the software is developed. And keep in mind, these are not detailed plans. These are the initial plans so that you know what you're dealing with. And furthermore, you don't develop these in any sequence. You develop all these things at the same time, and they influence each other. And I'll let you look at this slide and this slide on your own. It basically says you need to know what happened in the previous phase that might affect you, and you need to know what's going on in the next phase that you need to affect. I'll let you go through that. But anyway, I might ask you to explain, on an exam, I might ask you to explain what is the point of doing this during your initial planning activity, or something along those lines. Describe two outputs of initial planning and give an example why it's needed. All right, to summarize this module, base your initial plan on the scope of the project, understanding what its goals are, what the other parts are, what is the overall situation, who are the key people, who's got what responsibility, etc. That's the end of the module, and let's make it a 5-minute break this time because we're running a little late because of the time I spent explaining assignment 1. Okay, now we're going to start talking about software development plans. The reason this is important is because that's what your big assignment is for this class, is to develop a software development plan. And assignment 2 is your first draft of that plan. It's due in a few weeks. And just as assignment 1 isn't really graded, you're going to get a grade on assignment 1, but it doesn't count. When we take off 2 points for something, it means it's telling you this is about how important this is, and you didn't get it right or whatever. Same thing will happen with assignment 2. We will say, this part you got right, this part you would have lost 5 points if you had turned this in at the end because of whatever. And again, it's an advisory grade. It's giving you insight, giving you help so that the one you finally turn in at the end of the semester is better. That's the idea. But anyway, let's talk about software development plans. And I guess, I don't know what, there we go. We have to do that. All right. The objective of this module is to introduce the concept of a software development plan and to talk about the contents of a software development plan. And I am going to get something over here. There we go. All right. Now, here's what Dilbert has to say about plans. You gather information and then ignore it. This, unfortunately, is the way a lot of planning works. Now, remember what Eisenhower had to say about planning, where the planning activity is more important than the plan itself. But that doesn't mean you should ignore the plan. The reason for this comment is that very often people will write an elaborate plan to convince somebody to give them a contract, and then they won't follow the plan at all. And that usually doesn't work out very well. When I am talking about plans, I'm going to talk about 2 different interpretations of the word plan. When I use the plan in lowercase, P-L-A-N, all lowercase letters, I mean everything you produce as you plan, including drafts, including notes you take, including temporary versions of things, and so forth. It's the accumulation of all plans and related artifacts generated during the planning process. And when you're doing planning, you typically have a place like a folder on a computer or something like that where you stick all this stuff. When I use the uppercase P, plan, I mean a document that you call your plan. And basically it is the principal results of your planning. It's kind of the output of the planning process. So when I use lowercase p, I mean everything you produced along the way, and when I use uppercase P, I mean the formal document. What you're going to produce for assignment 2 and assignment 5 is a uppercase P plan. What you're going to do for assignments 3 and 4 is part of your lowercase p plan. You're going to do some stuff in assignment 3 and 4 that parts of which will end up in your final plan. So, the formal document describes your principal plans. Now, the first thing you might say is, well, in my kind of software where I work, we never develop plans, or at least we never develop formal documents, and that may well be the case. On the other hand, there are many situations where a formal document is mandatory. For example, I mentioned you get a request for proposal from the customer and then you give them a proposal. I propose to do this job for this much money in this much time. Well, if it's a big deal project like an airplane or an automobile or a database system for a university or something, they will typically want you to submit plans. And what they're evaluating is whether you know what you're doing. And that's exactly how I am going to evaluate your plan. When I grade assignment 5, and assignment 2 for that matter, I'm going to be saying, does this person sound like they know what they're doing? Imagine that each of you was a representative of a company, and I was going to pick one of you to be in charge of my project. I evaluate your plans to decide which one of you gets the contract. That's kind of the way I look at it. Now, it's not that only one of you gets an A. It's not like that. I remember once when I was a freshman in college, we were in a chemistry class with 300 students. And the professor gave this long description of how he grades the papers at the end of the semester. And then he says, and then I figure out who gets the A. And there's 300 of us thinking only one of us is going to get an A. And we weren't too happy with that concept. And then he explained that, no, a few more of you will get A's. But it's not that only one of you is going to get a good grade. It's just that the frame of reference I use is, do I think this student understands what they're talking about? Okay, so that's how I grade the plan. All right, here's another way of looking at it. The formal document is the output, but all these other things that are produced along the way may be part of your lowercase p plan. They're part of the planning activity, and they may be part of your plan in the sense that you may actually use them when you are developing the project. But they are not necessarily part of the formal plan. And as an example, your work breakdown structure, if it's in the plan, is usually in an appendix to the plan. That's the way it is for assignment 5, for example. Your estimates are usually summarized in the plan if they're there at all. Detailed procedures for how you do things are not usually in the plan. They're usually referred to in the plan. The plan says, we do testing using the such and such procedure. It's described in some other document. Why bother creating a formal plan? Well, it's a way to help you manage, because it's a way of documenting what you want to do and telling everybody what your plan is. And it's a way of showing people that you know what you're doing, that you have the experience, the knowledge, the understanding of the problem. In effect, your plan is your way of selling yourself, selling your ability to manage the project. That's what your plan is. It shows that you have done enough planning, that you understand the project, you understand the problem to be solved, you understand the risks, you understand how you know when you're going to be done, you know how to develop the software that needs to be developed, and you understand what the customer wants. That's how the customer will evaluate it. It forces you to answer a lot of questions. Questions that are easy to gloss over if you're not required to write them down. And that's really one of the biggest advantages of a formal plan, is that it forces you to think things through enough that you can write them down. And there's been a lot of psychological studies that show that when you write something down, you're more likely to remember it and more likely to understand it. When I was in that chemistry class I mentioned a few minutes ago with 300 students, the professor on the first day said, every night you should rewrite your notes in a more legible handwriting than what you wrote them during the class. And the reason is because in the course of rewriting your notes, you will try to figure out what did I mean when I wrote that? And you'll be eventually understanding what you're writing more effectively. And I did that. It actually worked quite well. It helps you manage because it communicates your plan to everybody else. And this is important when there's a lot of people involved. Your staff, other organizations you have to deal with, subcontractors. And it's a framework. Everybody knows the plan. This is why when you were a child in school, at least in the U.S., you practiced fire drills. They said, we're pretending we're having a fire. How do we get out of the building safely? And you all followed certain rules to get out. Why? So that if there's a real fire, everybody knows what to do, instead of everybody just panicking. The plan documents your assumptions. This is a really important point. And one of the reasons it's so important is this. When you are planning and you say, I'm going to do A instead of B, if somebody talks to you later that day and says, why did you pick A instead of B? You'll say, oh, it's right on the tip of my tongue. I know why I made that decision. I did this because of this instead of that. Think about what it's going to be like 6 months later. Why did you choose A instead of B 6 months ago? I don't know. I can't remember anymore. Well, the reason you write it down in the plan is so you'll remember it. You'll say, we could choose between A and B. Here's the pros and cons of A, pros and cons of B. We ended up choosing A for these reasons. Then if it comes up later that A turns out to have been a bad choice, you can look at that and say, oh yeah, well we made this assumption, which was a bad assumption. We really should have gone with B. So it helps you remember why you decided what you were going to do. And it helps you manage risks because it records your rationale for your decisions. It records, in many cases, you make backup plans. If this doesn't work, we're going to go this way. Your expectations, that sort of thing. It's important not to do too much. One of the mistakes people make is overdoing the formal plan. The formal plan should be a guide that'll help you manage, not a straitjacket that will prevent you from doing something that's sensible. And exactly what that means is something that you kind of have to learn along the way. In general, you put things in the plan that you're not likely to have to make a lot of changes to. If it's something that's detailed or something that may change a lot, for example, a schedule, you don't normally put the schedule in your plan. You put in the plan document, you put the schedule somewhere on the web or something, and then you have the plan may have a link to where it's located or something. And then you can constantly change the schedule without having to update the plan. It shouldn't contain detailed technical information about your product. It can contain high-level information so people understand what it is you're building. You don't have a plan that says, we're going to build something, but we don't know what it is. You don't want to do that. You want to say, we're going to build a database, or we're going to build a navigation system, or we're going to build a whatever, so people know what they're doing. But you don't want to put all the gory technical detail. That goes into technical documentation. You similarly don't put in detailed schedules and estimates. And you don't put in excessive detail about anything. The plan is the big picture view. Sometimes it depends on what your customer expects. The plan is, in a way, kind of like a textbook. It's something you learn from. It's something, imagine that the boss told you, I'm thinking of promoting you to a higher position or moving you to a more prestigious project. But I won't do it until you can name a substitute who can run your project. You have to name a successor for yourself. Well, how would you train the successor? Well, one way would be to give them the plan and go over it with them. Say, this is the plan. This is how you run the project. Okay. By the way, sometimes you have a series of projects that are always more or less the same. In that case, you may have a master plan, and then you make minor changes to it for each individual project. For example, I knew a group that made software to test hardware systems. And the software was always unique to the hardware system, but the general process of producing it was more or less the same each time. So they had a general plan for producing this kind of software, and then on each individual project, they would tweak the plan, or what's called tailoring the plan, to make it fit the details of that project. So they didn't have to go through the complete planning process every time. That's sometimes called a master plan. A formal plan should say a little bit about the product, mainly what does a software person working on the project need to know about the product they're building? What kind of product is it? Who's it intended for? What's it supposed to do? That sort of thing. What's important in terms of its performance? More about the project. Who does what, when, how? And a lot about the process. How are you going to do it? That typically is a large portion of your plan, is how we're going to do it. Where does all this information come from? It comes from the analysis that we talked about at the high level. The initial planning is where you start. Most of the descriptive information comes from initial planning. Risks are identified throughout the process, and when we talk about risk management, we'll talk more about that. But one of the things you should do when you work on assignment 2 is anytime you have a dilemma, I don't know whether this is a good choice or not, make it an assumption. There's a list of unknowns and assumptions right at the beginning of the plan. Say, I don't know whether we have enough programmers who know this language. And my assumption is we do, and my plan is based on that assumption. But the reason you want to document that is because that's going to directly relate to risks. Almost any time you make an assumption, that also translates into a risk. My assumption may be wrong. Now, some of these assumptions are pretty safe assumptions, but some assumptions are kind of risky assumptions, and that's something you have to judge when you get into risk management, which we'll talk about later. But it's important when you're going along and making decisions about your plan to say, I'm not sure about this. Well, that should translate into an unknown and an assumption and maybe a risk. Other planning information comes from your detailed planning. As you go through the various details of figuring out the cost and the schedule and all the rest, we haven't gotten there yet, you will identify other risks. For example, you want to reuse some of the software. You did another project 2 years ago that's very similar for part of the project. So you're going to reuse their code. Well, you may make some assumptions about that reused code, but you say that's kind of risky because the people who did it were a little sloppy in the way they developed software, and I'm not sure we can use it. So that might be a risky decision, and that might be on your risk list. So the detailed planning that you do will create additional potential risks. And the way risks work, just so you know, life is full of risks. You typically make this big, long list of all potential risks, and then you go through a process called prioritization, where you say, which ones really should I be worried about? And let's say you have 100 risks, and then you say, oh, the top 10 are the ones that I really need to worry about. And then you have a risk plan that focuses on the top 10. We'll say more about that later. Okay, by the way, people are incredibly bad about identifying risks. It's a human nature thing. So it's a good idea to talk to other people about what some of your risks maybe ought to be. And I'm going to set the following rule in this class. If you want to compare notes with another member of the class on things like what are the risks, it's okay to do so, provided A, you say so in your plan. You say, I developed this list of risks with cooperation with this other person, so that when we see the same risks on both of your reports, we don't think it looks like you cheated. And secondly, your discussion of what to do about the risk has to be your own. So in other words, deciding that something is a risk is something you're free to discuss with other people. What do you think the top risks are? Oh, what about this? Oh, I didn't think about that one. That's part of the risk management process, is talking to other people and seeing their perspective, and sometimes they see a risk you totally miss. Okay, now, tracing from the software development plan to your source documents is part of the process here. And the idea is, if you have a statement of work that says do something, and you have a section of your software development plan that says how you're going to do it, then you want to have a way of knowing that they're connected. Why? Well, suppose you change the statement of work. Suppose the customer changes their mind. You want to know what part of your plan may need to be changed. Conversely, what if you decide you can't do part of your plan the way it's currently written? You want to know how that relates to your source information, so you can know where you might have to negotiate something with the customer or with the system engineer. It's really easy to do this because typically what you do is you make a work breakdown structure which says everything you're going to do, and then you can add a column to your work breakdown structure that says where do I trace this to in terms of source documents. We talked about, or we're going to talk about that next week, I guess. And then I have another column that says where in my software development plan do I talk about how I'm going to do this. So it's fairly easy to do with a spreadsheet. You're going to have to do that as part of assignment 2, although the one that really matters is the one you do for assignment 5. You can show how your plan relates to the job to be done. Why is that important? Because one of the first things that will happen when you do a plan, and your boss will say, that plan is too complicated, we can't afford to do it that way. And you're going to have to defend your plan by saying, here's why I have to do this. The customer says in the statement of work that I have to do such and such, or this requirement says I have to do something. And by having this trace mechanism, it's very easy for you to defend your plan. I've been in situations where I went in the room and a chief electrical engineer went in the room and the chief system engineer went in the room, and my budget was cut by 10%, theirs were all cut by 50%. Why? Because I could defend my numbers. I could justify why I needed to do it. Okay, you can justify by tracing to requirements or statements of work or whatever. And the other thing is you can make sure you have planned everything that has to be done. If you have to do something and you can't figure out where it's covered in your plan, maybe you've overlooked it and you don't have a plan for it. All right. Let's talk about what goes in a software development plan. And this is very relevant to assignment 2 and assignment 5. Product information, project information, and process information. Now let me make a point here. I'm giving you my opinion. There are other people who will demand plans be done in a different way. So a lot of what I'm going to talk about here is primarily focused on what I expect you to do for assignment 5. All right. The product information, the main thing you want in your plan is enough information so that the person who's in charge of doing some of the software knows what they're supposed to be building. For example, scenarios describing how the system is used, an overview of the system architecture. What does the hardware look like? What processors are there? That's pretty important when you're writing software, is what computers, what processors does it run on? Brief technicians or discussions of any technologies that are unusual. We're using a particular weird way of doing something that's a little different from normal or whatever. Any key performance objectives that may relate to how you optimize the code, for example. And a lot of this information for Mr. Television is contained in the documents that I've given you. By the way, let me point out that I have a couple of situations where I intentionally didn't give you information that you'd like to know so that you will see a risk and it'll show up on your risk list. Or where there's contradictory information, in which case that's another source of risk. One source says it's going to be this big, another source says it's going to be that big, and they're not the same number. And you have to make an assumption based on all the information available to you. And I am not going to grade you on whether you pick the right one. I'm going to grade you on whether you have a justification for what you've done that makes sense. Product information for software is going to be more detailed because this is a software plan. I had a student in this class a few years ago who decided that the hardware design that I gave for Mr. Television was a bad design, and he was a double E student. He totally redesigned Mr. Television from a hardware point of view. I said, you don't get it. Software people don't get to redesign hardware. You have to live with the hardware you're given. And when you're doing a software plan, I mean, you can maybe negotiate something that you think is important, but you have to live with the hardware the way it's given to you and figure out a plan to build software on that hardware. You don't usually get to redesign the hardware. and so the Mr. Television, by the way, has been redesigned about 5 times in the last 10, 20 years. But anyway, I will be the first to admit that there's probably newer technologies that you could do a better job on Mr. Television than the one I have given you. But you have to live with the one I've given you, even though you may. And don't find hardware risks. That's not the point of this plan. The point of this plan is software risks. Okay, for each software item, what are the software items going to be? I've actually told you the answer. There's 4 software items in the case of Mr. Television. What kind is it? What is the function? What are the interfaces? What does it look like? What processor does it run on? What language is it in? And roughly how big is it? Again, imagine that you're a programmer being brought into a project and you want to know what the heck are we doing on this project. You look at the software development plan, you look at the section on the product, and it says, well, this is what we're building and this is how big it is, and so forth and so on. That's the kind of information you want here. And then there are risks related to the product. For example, our big concern here is the network might not be fast enough, or a big concern is that we may not have enough memory, or a big concern is, or you may have to figure this out. But the idea is, for products, you want to know what are the big concerns. For example, let's suppose the concern is you may not have enough memory. Then that affects the way you design the software. Or let's say the risk is that you may not have enough time to process the data. Well, that may affect the algorithm you use to process the data. So it's going to directly impact software, which is why you want that kind of information there. Here's examples of product risks. The processor may not be fast enough because the amount of processing required may exceed capacity. Memory may not be large enough because some of the software may take more space than we have. The network or bus may not be fast enough because the application requires higher bandwidth than is available. The product may not work as desired because the technology is inadequate. Sometimes what they want is simply beyond what you know how to do technically. Another thing that ties directly to those product risks is measures. How are we going to measure whether we have a risk? What are we going to look for? Well, how fast the software runs. As you start writing the code, you start testing how fast it is. Unused processing capacity. Required memory size compared with how much memory is available. Generally speaking, as you get further into the software development process, you can make more accurate estimates of how much memory is going to be required. So you can track that over time and say, how does that compare to how much we have? I/O channel utilization. Anything that tells you whether the product is going to meet its performance requirements. Now, let's switch gears, and now we're going to talk about the project. And here you worry about where's the money coming from, what's the organizational structure, how do we interface with the customer, where are we located, what facilities, organizational issues. Again, if you look at the outline of the SDP that's contained in one of the handouts, you will see the kind of information that's expected in the project section. What is our life cycle model? That is a key decision for your software. What is the integrated master plan? And the idea here is, what do we need to know about the integrated master plan in order to plan the software? What is the integrated master schedule? Same thing. Now, for purposes of this course, I don't have a bunch of electrical engineers for you to negotiate with or a bunch of project managers. So I'm assuming, what you have to assume is that what I've given you is more or less what they want to do and that they're reasonable in negotiation. So you just make that assumption and go with that. So if you think you need more time than they've allotted, assume that you explain why you need it and they agree and then they give you more time. Don't assume that they're intransigent people you can't negotiate with. What are the project milestones and goals? When are the major reviews? Are there times when you have to present your status things like that. What is the organization of the project, and where do you fit? And then what is the organization of the software? And what I'm expecting is a very high-level description of the project, and then a somewhat more detailed description of the organization of the software. I've had students who have an organization chart that shows 32 boxes for the project and 1 box for software. They got it backwards. For this course, I want you to have maybe half a dozen boxes or so for the project, and then wherever software fits in there, a lot more detail, maybe a dozen or more boxes just for the software structure. I remember one student had 80 software people, and his software organization consisted of software manager and 3 teams. And that's all. That's just not enough detail. The work breakdown structure, we're going to cover that next week, for the project, would be part of the project information, although typically it's an appendix. Any subcontract relationships, if they are there. What is the contractual relationship with this subcontractor? What are they doing for you? Risk management relative to the project. Now, remember, risks related to the product had to do with, will the product perform? Risks related to the project have to do, will the project perform? And that primarily means schedule and cost. Will I come in under budget? Will I meet the schedule? Now, anything related to that, for example, let's suppose you decide a big risk is high employee turnover. That may affect the schedule, in which case it's a project risk. It could also affect the technical performance because the people you replace them with don't have the knowledge to write the code or something, and that might end up being a product-related risk. So one cause could lead to risks in the product area and the project area. But keep in mind the difference. A project risk is something related to cost and schedule. A product risk is primarily something related to performance. Here's some sample software risks for a project. We may go over budget or schedule because requirements are too vague and likely to change, or because estimates are uncertain and possibly too low, because we have inadequate experience or training, because the product may not function as desired and we may require additional development work, because too many of our staff are likely to leave because our working conditions are really poor, or there's a competitor who's hiring away all our best people and offering them a lot more money, or we don't have enough people and we have a hiring freeze so we can't hire anymore. These are examples of software project risks. Here's examples of things you could measure to relate to these risks. For example, how much of our work is complete? That's what you're doing with assignment 1. You're tracking your progress and marking things off when they're done, right? So you can say how much of the work is done. How much money are we spending? Well, in the case of assignment 1, the money, if you will, is the hours you spent, but you're keeping track of that. Unplanned turnover. If a lot of people are quitting, then that tells you you have a schedule risk and a cost risk. Anything that tells you whether the project is going to meet its cost or schedule goals or any other project goals. Now, finally, we have process information. The process is how you're going to do the work. And this is usually where the bulk of the software development plan is. Methods and processes for software development. Now, I don't mean here's an 18-page description of our object-oriented design technique. No, I mean a statement that says we're going to do object-oriented design may be all you need, but that's the kind of information that would go in the plan. Milestones and reviews that you're going to have. When are you going to conduct reviews? What are you going to cover at those reviews? How are you going to manage your suppliers? Are you going to expect them to report certain things to you? Tools What tools are we going to use? What compilers are we going to use? What editors are we going to use? That sort of stuff. What are our plans for reusing software? We'll say more about that in about 3 weeks, maybe 2 weeks. Process improvement techniques. What are we going to do to learn how to do things better on the next iteration? Risk analysis. All the stuff related to risk management goes in the process category. Not identifying risks, but all the management of risks. What do we do when we have a risk? And the structure and procedures of our software development libraries. Where are we going to put software when it's finished? How are we going to make sure that we know which version of the software is needed for this version of the end product? Processes for all the support activities. How are we going to do estimating? How are we going to do quality assurance? How are we going to do configuration management? Process information is something that you identify throughout the planning process, and many of the details are not in the plan, they are in supplementary documents. And in the case of this course, you can just assume there's a document that describes it, but you have to list the document. For example, we're going to use a particular type of testing, and it's the details are described in our testing document. Well, there's another course at SMU on testing. I'm not going to repeat what's covered there. Again, you don't have to have all the gory details in your formal plan document. You can point to them. You give a link to where it's described on the web somewhere. Key risks related to the process. Now, what would be a risk related to the process? It's something about your process that isn't going to work or that might not work. For example, we've chosen a life cycle model that may not work for this project for some reason. Last week we talked about different software life cycle models and the pros and cons and the weaknesses and strengths of each one. Well, maybe you choose to use agile development and you decide one of the weaknesses of agile development is X, and we may have that problem on this project, so that would be a risk to our process. The process may not work right. The way you tailor the process may cause it to perform poorly. We'll talk about tailoring a little bit later, but the idea of tailoring is making the process fit the details of your situation. Well, a very common mistake is to tailor out all the quality activities because you think they take too much time, and then later on you run into all sorts of quality problems. You decide you don't need to do code inspections except on the final iteration. Well, maybe that'll introduce a risk. Maybe the process will be hard to implement because it's hard to manage, or it's hard for people to learn how to do it right. That's another example of a process risk. Here's some examples of things you might measure that relate to process risks. How well are we finding problems during our inspections and reviews? Okay, maybe you count how many problems you find or how often you run into problems that you should have found sooner. If you keep running into problems that should have been found earlier in the process, that tells you have a process problem. Defect levels. Rework. How much rework do you have? The more rework you have, the more inefficient your process is. How many incidents do we have where we don't follow our process? That's something you could measure. How many incidents do we have where the process doesn't do what it's supposed to do? Doesn't accomplish what it's supposed to have accomplished. For example, you spend a lot of time doing code inspections and they don't find any bugs because you're not doing the inspections right, because the inspection process is too hard for people to follow correctly, or you're not requiring people to do it properly. Anything that tells you whether the process is being followed or whether the process is or is not achieving its objectives. Now, typically, a formal plan will refer to other things or else put them as appendices. In the case of this course, I have you put them in appendices just for the convenience of having it all in one document. But for example, standards, procedures, schedules, estimates, shop load. A shop load is something that says who's going to do what each week. A shop load is kind of like a detailed assignment of people to tasks. Specific assignment of resources and people to particular tasks. Details of the software engineering environment. In other words, in the plan you might say, we're going to use this compiler and we're going to use this editor. Whereas your details might say, oh, here's the details of how we're going to construct our network and here's all the protocols we're going to use and all that stuff. The stuff that an IT department might put together would be not belong in your plan. Now, in Module 8, the next module, I'll say a little more about this. I want to say a little bit before we take our next break, I want to talk a little bit about maintaining an effective plan. There are many standards for software development plans. They range from write it on the back of an envelope to here's a 250-page model plan that you have to follow exactly. And sometimes your organization defines how the plan should look. Sometimes your customer defines how the plan should look. Sometimes it's a matter of you using common sense to say, for my project, here's how much I need to put in my plan. So I'm not recommending that any one of these is the right model. I just wanted to go over briefly a couple things. There's an IEEE, ISO stands for International Standards Organization, and I forget what IEC stands for, but IEEE is the Institute for Electrical and Electronic Engineers, which is an organization that plays a big role in computer-related standards. And their standard 12207 is kind of the major standard for developing software. It's primarily aimed at big projects, but I thought you should know it's out there. If you were to look at it, you'd say, boy, that is a lot more complicated than anything I would want to use. But if you ever get a big contract, you might have to use it. These other two were predecessors of that. They were actually very well thought out, but they're pretty complicated. And they're designed for really, really big projects. Your industry might have standards. Your company might have standards. Your organization within a company might have standards for plans. And the advantage of a standard format for a plan is that it tells you all the things you should be planning. And the other side of it is it helps others know where to look for answers. And that really comes into play here. For example, when I bid on government contracts for a number of years, I always followed one of these three standards, depending on, this is what I used in the 1980s, this is what I used in the 1990s, and this is what I used in the 2000s. But the point was, why did the government say, I want you to write your plan in accordance with this standard? It's really simple. There were 8 companies bidding on the contract. Each plan was 300 pages. They had to review all 8 plans and see which ones they liked the best, and they wanted them all to be in the same format so it was easy to compare them. That was the reason they had a standard plan. The same thing applies within your company. If your company is deciding whether your plan is any good, if the company has a standard plan, they will compare your plan with their standard plan and see if you know what you're doing. It's a lot easier to understand. This is why I give you a standard plan format. So when I have to grade all of these, and I have 2 days to grade them all, I have a standard, and I expect everybody's information on this or that subject to be in the same place. So I know where to look for things. Okay. It tells you all the right questions you should be asking, and it helps others know where to look for the answers. Drawbacks of a standard plan. The standard plan may not fit your situation. You may feel that you need to deviate from it. And the other thing is what I call the boilerplate mentality, and I'll explain that with this true example. We had a plan, a project that had an excellent plan. Everybody gave it all these high praises. Wonderful plan. So one of the people who worked on that project was assigned to a new project. And he needed to do a plan for the new project. So he took the plan for the old project, which everybody said was a wonderful plan,
And he did a global replace of old project name with new project name. He said, there's my plan. And everybody said, oh, great, wonderful plan. Looks fabulous, right? Keep in mind what Eisenhower said, planning is what matters, not the plan. This guy had a great plan, but not for his project. He hadn't thought about his project and what was unique about his project. And so he got into, everything got approved, he started working on it, and all of a sudden he started realizing that he was required to do things that didn't make any sense for his project to do. He had left out things that were important for his project, and it was a total disaster. Great plan, but it didn't fit his project. So that's what I call boilerplate mentality. The tendency to think that once you've done a good plan, that applies to every project. That's not necessarily true. Okay. The plan is static. The planning process is dynamic. So you need to plan to update your plan. That should be part of your plan. You learn more every day. And the plan should reflect what you know today, not what you didn't know a month ago. So you need to keep your plan up to date. On the other hand, you don't want to change your plan every day because then nobody follows the plan because they know it's going to change anyway. So you have to be methodical about it. Don't make your plan and then not tell people that you've changed it. They're still operating on the old plan. You have to make sure that you do it in some kind of a sensible, like at major reviews, you update the plan or something like that. Beware of bureaucrats. If you are in an organization where somebody has to approve changes to your plan, then think really carefully about what you put in your plan. Because if there's something you think you're going to want to change, and if a million bureaucrats have to approve it before you change it, that's going to make it hard to make the change, right? So one of the things you can do is have a plan for changing the plan and put that in your plan and say, we're going to make minor changes this way and the bureaucrats don't need to look at it, and the major changes the bureaucrats can look at, whatever the correct words are for saying that. And then you can make the minor changes without requiring all the approvals because you put that in your plan, and once they approved your plan, they approved your process of improving the plan. So you have to be a little careful if you're in an organization where there's a lot of bureaucrats, a lot of approvals needed to get changes. Avoid excessive detail in your plan. Put details in supplements, in websites that you link to. I already mentioned putting a plan for changing the plan, and there's always the duplicate plan concept where you have a formal plan that doesn't ever change or doesn't change much, and then a working plan that gets into more detail that's changing all the time. The more customers and managers trust you, the less likely they are to want to approve every little change you make in your plan. All right, to summarize, the software development plan serves many roles, and the formal plan is kind of the principal high-level elements of your plan. And there's lots of other parts of your plan in the lowercase p sense that are supporting it, like your schedules and your things like that. Planning forces you to think. Documenting your plan helps you avoid glossing over issues that you should go to the trouble of thinking about and writing the answer down. Plans have to be maintained and updated in order to be useful, but you need to communicate changes, and you don't need to do it too often. And the standard plan is like a checklist. Okay. Now, before I finish, I want to compare what you do for assignments 2 and 5 with a real software plan on a real project. On a real software plan, you'd have either a summary of your integrated master schedule, or you'd refer to the integrated master schedule by giving a link to it or something. In assignment 2 and 5, I want you to have 2 integrated master schedules. The initial one is the one that you put down for assignment 2. And the final one is the one you put down for assignment 5. And what happens in between? you've taken the rest of the course, you've done assignments 3 and 4, you've learned a few things, and you've decided the plan needs to change a bit. And then you're going to explain why they're different. Now, in a real plan, you wouldn't do it that way, but I have to be able to grade how much you've changed it, and that's why I ask you to do that. In a real plan, your tools would be in a separate document. Whereas in assignments 2 and 5, I want you to give a high-level summary of your tools in the plan. In a real plan, risk, measurement, quality, CM plans would be separate documents. In this one, they're appendices, except you don't have to do CM and QA plans. In a real plan, the work breakdown structure and the estimates would be separate things. In assignments 2 and 5, you do the work breakdown structure and make an appendix, and your estimate, you put a summary as an appendix. Why? Because I need to grade it, I need to look at it, and I want to have it in one document. That's all. So I want you to understand that what I am having you do for assignments 2 and 5 is not exactly what you would do for a real project. Okay, that's the end of the module. Let's take another 5-minute break. Okay, let's cover software development plans part 2. And let me just make an observation here. I break this course up into modules that are sort of all nominally 50 minutes long, but some, as you've noticed, are a little shorter than others, some are a little longer than others. Tonight's one of those nights when we're going to use up all available time. Other nights we're going to run a little short. That's kind of the way it works. Okay, let's talk about part 2 of software development plans. We're going to talk about some specific contents of some specific parts of the plan. I want to point out that there are later modules in the course that cover material pertaining to other parts of a software development plan. So as you go along, you probably want to make yourself a little chart that says this module addresses this part of the plan. And as you go along, you're going to find other modules addressing other parts of the plan. So what I'm going to talk about here is a little bit about project information and process information. Let's talk about selecting methods and tools. One of the things that they typically ask the software team to decide is what tools and methods are you going to use to develop your software. And as a software leader or software manager, you have to decide between reliable, proven tools and methods versus innovative, improved tools and methods. Generally speaking, the reliable, proven tools and methods, you have data to support things like how efficient they are and how well they work and where their strengths and weaknesses are. If it's a new improved tool, it has the potential of being better, but it also has risks associated with it. It may not work with something you have to work with. It may fail when it, one of my favorite examples is a tool that looked wonderful on paper, but it couldn't handle a project as big as our project, and we found out about halfway through when it failed because we were too big. What are you going to do then? You've been using this tool all along. Developers usually want the latest and greatest because, after all, they're trying to be at the front of their own field. Developers are generally very optimistic about how wonderful these new methods are. But newer tools can mean risk. For example, they may not integrate with other tools and methods that you have to use. They may produce output in a format that your other tools can't read. You may have to train people. That means you have to spend time to train them and money. It may take time to learn how to use the new tool efficiently. You're probably going to make mistakes with the new tool because you're not used to it. Some tools cost a lot of money. And one thing that's not on the list is sometimes a new tool sounds great, but the person or the company that makes the tool goes bankrupt. And then there's no support for the tool. Sometimes your customer or your project manager may have an opinion. They may insist that you use the new risky one. This is a very common problem with government projects, believe it or not, because somebody convinces the government that this wonderful new approach is a better one, and then all the bureaucrats bow and say, okay, all new projects have to use this new approach. And you find that, hey, it doesn't work very well. On the other hand, they may insist on using something that's well established, that they trust and that they're comfortable with, and you may say, yeah, but you're old-fashioned. I want you to do it the new way. And to give you an example, the FAA, the people who control what software you write on airplanes in the U.S., only recently allowed you to use object-oriented techniques for airplane software. And object-oriented techniques have been around for 40 or 30 anyway years. Your job as the software leader or the software manager is to get the software done on time and on budget. That's what you are being evaluated on. So you have to think about this. You know, what are the pros and cons? What are the risks? Trade studies, this is where you look in depth at the different options and say which ones are better, what are the strengths and weaknesses of each option. And keep in mind that technical people usually have favorites. So when they do technical studies, they usually find a way to make their favorite look best. So you want to get some people who have different points of view involved in this. Get inputs from people who have already used the new methods. One of the best ways is to go to the web and look for blogs where people complain about methods. Almost any tool that's out there, you're going to find a place where people complain about it, and you want to see what they're saying. Are they saying it's really good, or are the things they're complaining about relatively minor, or are they big deal problems? Some tools have user groups where people go to a conference and talk about the tool, like Usenix is where everybody talks about Unix and Unix-related products. Well, that's a good place to find out what things work and what things don't work. Another thing you consider, if you're trying a new tool, try it on a small prototype effort before you try it on a big, important project. Make sure you know how it works, whether it works, etc. Other things to consider with a tool. What does it cost? And is it available? Maybe you can't get it easily. What about the training? Is the training available? I remember we bought a tool one time and the training had such a backlog it took 1.5 years to get our people trained because the company hadn't created enough training resources. Is the vendor going to be around 5 years from now? The company that makes the tool. What computers and operating systems does the tool run on? Let's say it runs on Windows 7 and Windows 10 is about to come out. Are they going to update it to run on Windows 10? And what is their schedule for doing that? Maybe that affects whether you want to use it or not. Compatibility with tools and methods you use for other purposes. What training is really required? How long will you need to maintain the software that you're developing? And will the tool be around long enough to do that maintenance? Your plan should document the tools and methods you're going to use, why you use it, what the purpose is, how you're going to acquire the tool, especially if it's not an off-the-shelf tool, but if it's a tool where you have to go to some company and have some specialty tool. Sometimes that's important for test equipment, and for example. And a rationale for why you're using it. You might make a little table like this one. There's a table like this in the model plan or the template plan. What phase of your development process, what tool you're using, who your vendor is, and what your purpose is. Again, for purposes of a software development plan, you don't need much more information than what's on this chart. But the idea is you want to show that you've given it some thought, that you haven't just arbitrarily decided we're going to use C++ because that's what we've always used or something like that. Let's talk about facilities and staffing plans. The top graph is an unrealistic staffing plan. You got 2 people in month 1 and 19 people in month 2 and 5 people in month 3. You can't run an organization like that. The bottom one is much more realistic. And when you're planning your staffing, you might want to think in terms of how can we plan our schedules so that our staffing is reasonable. I remember one time when a company was making a proposal where they had nobody in month 1, they had 52 people in month 2, 53 people in month 3, and they were down to 5 people in month 4. And our question, well, where the heck are you going to get all those people to come to work for you for only 2 months? It just didn't make a whole lot of sense. People cost money. The important thing to remember if you're the manager is your job is to make sure the people are producing a lot of results, which means make sure they're adequately trained, make sure they have adequate facilities, and don't keep interrupting them and asking them for stuff that you could have provided yourself. Your job is to make them productive, not to take work off of your back. A lot of managers think my job as a manager is to make everybody else do my job. No, your job as a manager is to make all those people who work for you as productive as possible. Make sure the facilities are appropriate for the work you have to do. this gets to be a real challenge sometimes with a big project. If you have 100 people working for you, you need to think a little bit about exactly how we're going to physically lay them out. Which ones are going to be in near vicinity of each other. By the way, I was reading an article just the other day in the Wall Street Journal. They were saying that they've learned that a lot of open offices, which everybody thought was such a great idea 5 years ago, are proving to be a big failure. And the big reason is the noise factor. When you're too close to somebody else and there's not much of a partition between you, the other person makes noises. They eat, they call somebody on the phone, they do whatever they do, they have a conversation. And the noise factor tends to be really high, and that tends to make people less productive. You should talk about what facilities you need, especially, again, at a very high level, but you need desks for 40 people. You need PCs for each one of them, or whatever. You're going to need a network to tie them all together. There's a section of the software development plan where you talk about the staff. How many people do you need in which category? And what skills do they have to have? You don't just say we need 50 programmers. You need, okay, we need 10 people who know C++ and 15 people who know how to do this and that sort of thing. How do you manage risks related to people? For example, if one of your risks is people don't know a particular language, maybe you have to have a plan for managing that risk. Maybe you have to have a training in how to do it available if needed or something like that. Let's talk about the process. You need to document your process so that everybody knows what to do. Now, exactly how much detail you have to provide may depend on the people and their experience and the company's standards and all sorts of other factors. But if people don't know what they're supposed to do, you're paying them to fool around and make a lot of mistakes. We did a project at Raytheon where we studied projects and we ranked the projects by how far over budget they were by the time they finished. And then we did a statistical analysis of which factors correlated with being late and being over budget. Number one factor that caused you to be late and over budget was failure to follow your process. Everybody did something different and then it didn't work together and it got to be a lot of rework and a lot of conflict and so forth and so on. Okay. Your software process is the details that are sort of more detail than what's in your lifecycle model. And this is something you document to a certain extent anyway in your software development plan. There's a whole section on how to do that and a model example of what a table would look like to describe that. The basic idea is you take all possible software life cycles, and as part of your initial planning, you choose a high-level life cycle, or maybe more than one if you have significantly different kinds of software. And then you tailor it to the details of your situation, producing your specific process. And a good example of tailoring is you decide not to do detailed inspections until you get to the third iteration or something like that. Or you decide to use pair programming for the first 5 iterations, and then you're going to use more thorough peer reviews for the last 2 iterations or something like that. Anything at all that is designed to make the process better fit the circumstances of your situation. Tailoring starts with a standard process, and you can delete things you don't need, and you can change the scope of things that ought to be done differently or to a different level of formality or a different level of detail or whatever. You can also add things. Again, it's like tailoring clothing. When you go to a store and you say, I like that suit, but it doesn't quite, it's my size, but it doesn't quite fit me, and the tailor makes it thicker here and thinner there and longer here and shorter there. That's kind of what you're doing when you're tailoring a process to your situation. Maybe you tailor it to the people. We have people who have certain characteristics, and therefore we do things slightly differently. The risks of tailoring are things like deleting something when you don't know why it's there. And I like to use the example of you give a child a toy and the child takes it apart and then puts it back together again, and then there's parts left on the floor. And you say, well, why is that spring there and why is that lever there on the floor? Well, I didn't know where they went. Well, you're pretty sure there's a reason why those belong in the toy, and it's probably not going to work right, right? Well, when you tailor a process, you need to know why everything is there so that if you decide to take something out, you know why you don't need it. Sometimes you take something out because you can't understand why it's needed, and then somebody else needs it and you didn't produce it. You have to make sure you know why it's there before you take it out. Same thing with an artifact. You can delete a task because you don't know why you're doing it, or you can delete an artifact because you don't know who needs it. But if you find out later somebody did need it, then you're in trouble. Changing the process to save time or money may add risk. Like you say, okay, we're not going to do as thorough an inspection process. Well, maybe you're going to increase the likelihood of bugs. If you find yourself in a position where you are documenting an organization's process, you might want to consider the following. When you document an organizational level process, like this is the way we do code inspections in our company, you should explain why each task is there, who depends on the output, similarly why each artifact is produced and who needs it, what are the risks of deleting or modifying the task, and any suggestions about tailoring. For example, if you're doing a non-deliverable prototype, you don't have to do this qualification test or something like that. It's very similar to the advice you might give in a recipe. If you are in high altitude, you need to add more salt or something like that. Or if you don't have egg whites, you can do such and such instead, or whatever. And you document your tailoring decisions, so again, for the same reason you document anything else. So you remember why you did it. And sometimes you take something out, like in this example, you took out a design review because you had a short schedule and you thought you have good designers. And you know that it increases the risk that you'll have a design defect, and maybe you need to monitor something to see if you're having too many design defects, because you know that there's a risk of having design defects because you took out the design review. In other words, every time you tailor, there's a potential risk. Here's an example of a tailoring checklist. Here's a step of the process or an artifact you produce. Here's what you did to tailor it, and here's your reason for doing the tailoring. I used to work for an organization where whenever you tailored the standard process, you had to show this checklist to the boss, and the boss had to approve it. And so your rationale had to say, well, this is why we made this change. And the boss, who had been around for a lot longer than any of us had, often would say things like, no, I won't let you do that because I've been bitten too many times by people who tried to do that and then got into trouble. So, but anyway, it's a good idea to document this kind of information. There's a table like this in the Model Software Development Plan. Appendix A has some suggestions for documenting a process if you're interested. Now let's talk about documentation plans. I want to introduce the concept of an artifact versus a document. An artifact is anything you produce. A document is a particular kind of artifact, but there are other kinds of artifacts. Object code is an artifact, but it's not a document. Requirements model is something that's contained within a tool, a requirements design modeling tool or something. The design of your system is an artifact, but it may or may not be represented in a document. Sometimes it's just represented in a tool of some sort. It's better to think of your process as producing artifacts rather than to think of it as producing documents, because some things may not be suitable for documents. Many of the artifacts that you produce are constantly changing, and others just don't make sense to put in a document. On the other hand, some things make sense to put in a document because they force you to document them, and it forces you to think about them. Paper documents represent a snapshot of reality, but as soon as you put it on paper, any changes you make from that point forward are no longer reflected in the paper document unless you change the paper document. If the documented item is frequently changing, paper document has to keep being updated, and that can get to be a lot of trouble, a lot of overhead. Creation, storage, and maintenance of paper documents can be expensive. The advantage of paper documents is it's permanent. You have a permanent record. And if you have multiple people working on the project, a paper document that you give to everybody helps make sure they all see the same thing. Documents tend to outlast the project. An archaeologist 2,000 years from now may find your software development plan interesting if it lasts that long. Probably won't find your design model interesting because they won't be able to reproduce the tool that incorporates your design model. Documents are human readable, which forces you to explain things in a way that humans can understand, and sometimes that's a big plus. Documentation for software is like documentation for plans. It's a snapshot of your status, but it changes all the time. Many contemporary software development methods and organizations don't use paper documents. They just use online things because they change so much. There's no point in printing them because they're going to be obsolete. And more we go to putting things on a web and then updating them online rather than producing any kind of paper document. But you have to plan your documentation and your artifacts. You have to say, this is what I'm going to produce. This is the format it's going to be in. There's a table in the model plan or in the template to show that. You know, this is the document, this is the format, this is when I produce it, this is what it's needed for, that sort of thing. Here's an example. Here's the artifact, here who produces it, and who produces it is a process step. Who uses it, same thing. It's a step of your process that uses it. Who controls changes to it? In other words, can anybody change it, or is there a particular job or a particular role responsible for changing it? And what format is it in? Keep in mind that documentation is part of your configuration. And what I mean by that is, let's say you have a version of the software and you come out with a new version where you've made some changes. Well, there may be documentation that has to change as well. One of my favorite examples is I got a new version of one of the Microsoft Office tools. I think it was Excel. And the new version worked a little differently. So I went to the help file to ask how to do something. And it gave me information on how to do it using the old version, even though that was the help file provided with the new version. They hadn't updated the help file to be consistent with the changes. So it was a worthless help guide because it was telling me how to use a feature that didn't exist anymore and didn't tell me how to do it using the new system. So that's what we're trying to say with this diagram, that if you update the software, you have to make sure that any documentation that the customer will see, or really that anybody will see, is consistent with the change. People who are in charge of software maintenance complain about this all the time. They say, they updated the software but didn't change the design information,
and now the design doesn't match the code, and I don't know which one's wrong. You need to know what artifacts you produce as part of your process. Appendix B has an example. But different software development lifecycle models call for producing different kinds of artifacts. Let's talk about reviews and audits. Reviews are things whose purpose is to learn the status of the project. Typically what happens is the software developers present the status of things to the managers or to their peers. And they typically, a review will typically last a few hours. Sometimes they'll go on for days, but some are relatively short. It tends to uncover problems, and it tends to get everybody synchronized. A drawback of a review is that it doesn't always identify solutions. It's better at identifying problems than identifying solutions. And it could motivate people to hide problems. If you are in a company where you go to a review and if you report bad news you get punished, then guess what you do? You try to avoid reporting bad news, and therefore the managers don't know what's going on because you haven't been willing to tell them how much trouble they're in. I worked for Texas Instruments at a time when they made a product called the TI home computer, and they were having a major problem that the people making the home computer weren't willing to tell the boss because they were afraid he'd yell at them. And as a result, the company lost some enormous amount of money. What should have happened is they should have said, we're having this problem, we need help. The reason they didn't is that the boss was notorious for yelling at people when they reported bad news. Well, that's what you get when you behave like that, is people aren't willing to tell you the truth. So it's a bad idea. A big advantage of reviews is that they're relatively inexpensive. And one of the things you can do with reviews is to standardize them. We always show the same 10 slides or something like that. That way it's easy to prepare, and it's easy for people to understand what you're telling them because there's a standard way of communicating. Reviews tend to get everybody back on track. Now, let's talk about categories of reviews. There are 3 categories that I'm going to describe here, and they are described slightly differently in the software development plan. What I call the management reviews, that's the first 2 categories, are divided into what I call phase or milestone reviews, sometimes called gates, and status reviews. A milestone review is something that occurs at a major milestone in the process, the end of design, the point where we completed all the tests, or some such thing as that, when the requirements have met a certain standard. And the idea is, have we done what we should have done? Are we ready to move on to the next major step of the process? A status review is held on a regular basis, daily, weekly, monthly, and it's designed to say, how are things going today? And so they have an entirely different purpose. The status review is focused more on the near-term issues. The phase or milestone review is focused on major decision points or major milestones of the project. Now, the third type of review is called a peer review. And this is actually a different kind of animal. It's known as an evaluation. An evaluation, the focus is not on the project, it's on the product. You're saying, how is the software coming? How are we doing in terms of the technical aspects? Peer reviews are typically attended only by the workers, by the developers, not by the managers. Whereas the first 2 kinds of reviews are done by the managers. And you'll notice in the model software development plan or in the template that these are covered in different places. The management reviews are covered in one place, and the evaluations are covered in the same place as you talk about testing. This is a little more detail of what I just said. The phase or milestone reviews occur at the end of a major phase, and they help you make decisions. Are we ready to move on? Did we accomplish what we intended to?
Here's the kind of things that would be covered. I'll let you look at this because we're getting close to running out of time here. But you can look at this list. Status reviews are on a regular basis scheduled on the calendar, once a week, once a month, once a day. And they tend to identify near-term issues. We're having trouble with this. We need to change something here. And these are the kinds of topics you would cover at a status review. And one of the things you do in a status review is you talk about what you think is going to happen by the next review. For example, you give action items to people and say, I expect you to resolve this by the next review. And the other thing you may do is look at the action items from the previous review and say, what's the status of all those action items? You tend to do that sort of thing during a status review. Peer reviews is a way to evaluate specific products or artifacts. Is the code passing the tests? Is the code following the standards or following the coding standards or whatever? And it's typically attended only by the peers of the person doing the work. That's why they call it a peer review. Only peers because you want open discussion and you don't want to embarrass yourself in front of the boss. That's basically why you do peer reviews. So you can say, I screwed up, I left out a comma, and it doesn't, the boss isn't there thinking, oh, that's an idiot, he doesn't know how to put the commas in the right place or whatever. Peer reviews and inspections, one of the most important things to keep in mind is that each person needs to help the other person. If you have a culture where people aren't willing to help each other, then peer reviews may not do you much good. Now, I've been in organizations where your performance review was partly based on how good your peer review participation was. So if you gave good suggestions to other people during peer reviews, you would get a better performance review just because you helped other people. I've seen a culture where every young person or new person was connected to an older, more experienced person, and the older person's performance review would be based in part on how well the younger person did. So therefore, the older person would review the work of the younger person and gave them good suggestions so they'd do a better job. So there's all sorts of different ways to foster more effective peer reviews. What you don't want to do is force everybody to do peer reviews without motivating them to do a good job of peer reviews. Audits. The purpose is to look in detail and find problems that are not evident from the surface. And I have to rush through this because we're just about out of time. Audits may take several days or weeks. They usually uncover problems. They usually involve outsiders looking in and seeing things that the insiders don't see. A human characteristic is to not see things when you're on the team, but an outsider looks at your team and immediately sees something you're doing that could be improved. It's just human nature. Audits tend to uncover real problems and to confirm or disprove suspected problems. So they're usually used to probe more deeply than the conventional reviews I already mentioned. The drawbacks of audits is they're expensive. They only identify problems. They don't necessarily identify solutions. And again, they may motivate hiding of problems. And if you don't handle them right, they can generate hostility. Because if you tell your software staff, we're going to audit you, their immediate reaction is, why? What are we doing wrong? You don't trust us. One of the best ways around that is to make it part of your process. We always do an audit when we get to such and such a step. And I've seen organizations where they're proud to be audited because they know they'll look good. But that's a cultural thing, very much a cultural thing. Get the practitioners involved in doing audits. For example, where I worked for a number of years, we audited each other's projects just to have somebody from another project look and see if they see something. It was really quite effective. And you don't punish people for problems found during audits because otherwise they won't cooperate with audits. All right, to summarize,
there are many possible topics to be covered in a plan. We've covered a few of them here. There's more coming, but always base your plan on the needs of your project. That's the end of the module, and that's the end of tonight's session, just in time.